Okay, so what we're going to do is we're going to design a racetrack for the line follower robot. And the way the line follower robot works is he can accurately detect light colors and dark colors. So since I'm not sure what color the floor is, and this is a perfect example of the robot's not sure what color this floor is either. That's why we have the white track, so he knows like the base color, and the black, which is the line he'll actually follow. So the constraints on this, there's a couple constraints. So one constraint is don't do any angles more than 45 degrees. So smooth curves are okay, but if you have any, like for example, if you did a 90-degree turn, the robot would just see the 90-degree turn, well, it wouldn't see it, and it would keep going straight. So when you're designing the track, try to keep it to no sharp angles more than 45 degrees. The other constraint in general is if a corner's too sharp, it'll have trouble, but it might make it. So you can experiment. And the most important constraint is I'm not interested in carrying the tape home.
Okay.
So make a big track. And have fun. All right, so here, have some tape, Darryl. Have some tape. And you guys can figure this out. Be creative, try different things, and we'll see what works, what doesn't.
You want a circuit, right?
Well, it doesn't, the beginning and the end of the track don't actually have to connect. If they do connect, it'll continue. But if they don't, then we'll just stop the robot and start it somewhere else. It's all good.
We could loop, we could start here, loop, and come back, and these are three places.
Sure. Yeah. Think more Formula 1, less NASCAR. Maybe no careful turns.
Yeah, actually, the robot has made it around some sharper corners than I would have expected. So, all right. So just so you guys get an idea what it looks like. This is the little guy that'll be attempting to follow the line.
So you want me to go all the way back straight? Sure.
All right. So can everyone else mostly hear me over the construction, the road construction?
So this has to go on top of this.
Yeah. Just put it straight down the center. All right, so the fact that nobody said no, I'm going to assume the answer is yes. You can all hear me. So we're gonna chat about some of running Java 9 on Raspberry Pi while we're constructing the demo. But if at any point you get tired of hearing me talk, feel free to jump in and help with the construction project. This is a group effort. So my name's Stephen Chin. I'm the director of the Oracle Technology Network and the Java guy, Java 1 Content Chair, Oracle Code Community Chair. And I also play with lots of embedded hardware and stuff as a hobby. So I wrote a book, Raspberry Pi with Java, and I'm playing around with various CNC cutters and 3D printers and other large, dangerous hardware. Actually, one of the projects which we had in mind for Java 1 this year is we wanted to do a full-size, like full-scale foam 3D printer using audio scaffolding. Kind of like how they make these. This room doesn't have it. I think that's not actually scaffolding, but sometimes like in large conference rooms they'll have the scaffolding overhead. So you can actually use that as a structure to create a massive 3D printer. So we were thinking of doing that. Anyway, we'll see if we actually have time and energy to do that or not before Java 1. But now we're going to chat about Raspberry Pi and specifically running Java 9 on the Raspberry Pi. So how many of you guys have a Raspberry Pi already? OK, awesome. So everybody who didn't raise their hand, do you have $40 in your wallet? Yes, OK. So you should convert that $40 into a Raspberry Pi because it's much more useful. So Raspberry Pis are fairly inexpensive. Basically, it's a small embedded computer It uses an SD card as a hard drive. You can power it over like a simple 5-volt connector from like a cell phone or something, a normal micro USB jack. And compared to your average embedded platform, it's super easy to get started with. Hey, Nikhil. If you have any ideas for the track, jump in and help out. So it's like super easy to get started with. So traditional embedded boards that people use for their jobs, like development boards, like Panda boards and other devices, the setup and getting drivers loaded and getting serial tipping in and getting all the firmware set up and all that great stuff, that's easily a couple weeks of headaches with like bad software and poor quality control on boards and funky drivers and different revisions of the board and all the other things you have to deal with. But the Raspberry Pi Foundation, they actually are using similar hardware to what you find in a lot of embedded development kits. But their goal was to make this a computing platform for education and for specifically like teaching kids. So as a result, one of their design goals was to make it as easy as possible to get up and running. They've kept backwards compatibility of the operating system all the way back to the first revision of the board, which is pretty much unheard of in the embedded industry. They also designed a super easy embedded installer, so you don't even need to hook up to the hardware with serial or do anything crazy. You just take the SD card, copy the installer files to it, and it automatically takes the FAT partition, reformats it to ext4, sets up the Raspbian operating system, which is a variant of Debian, and takes care of everything for you. So it's like in a couple hours, you're up and running if you know how to put an SD card in your computer and copy some files. So super easy. Highly recommended to get started with, and you can run the latest versions of Java on it. So Raspberry Pi distributions come with a version of Java 8. You can install early access versions of Java 9 and play around with them. So that's what we have on this guy today. We're running Java 9 on our little line follower robot. And there's a bunch of advantages for running Java 9 on small devices. Actually, a lot of the main feature in Java 9 is modularity. And this actually is great for embedded devices because you have constrained space and resources. And this allows you to pare down the JDK to just what you need, package up things together into small runtime images, which just include the modules which you actually need for your environment. The way Jigsaw, which is the project name for modularity, is structured, is it's structured into a bunch of JEPs, which is the Java enhancement process. So there's a JEP for the overall module system, modular JDK, modular source code, modular runtime images, and then a couple which are related, like JLink and encapsulating the internal APIs. So this one's interesting in itself, the modular runtime images. So one of the improvements in Java 9 is that we're finally getting rid of zip files, which has been around forever. So actually an optimized, efficient way of storing class files, more space efficient, easier to load things. Will be much easier for example embedded devices doing this, and it can be extended for different data types in the future. So it's an optimization, but it will also help out with resource-constrained platforms. Another improvement is JLink. This one's particularly important because this allows you to just link your application with the modules you require and create a simple runtime for it. So you can create a customized runtime for just your own application, which just pulls in the resources you need. It's a tool you run from the command line after compilation. It'll pull everything in and gives you a kind of a consolidated application that you can run on your device, which just includes exactly what it needs. So you don't need a full Java or JDK or JRE installation on your device. You can just put your application and it has everything it needs, and it can be run in a fairly small footprint. You want me to go back a sec? All right. The next thing I'm going to talk about is JShell. And this is something which most programming languages have. It's a read eval print loop, or REPL. So Java finally has an official REPL. And this is a great way to go on the command line and actually try things out without actually going through a full compile phase. It gets rid of some of the syntactic sugar around the Java main class and all that stuff, so you can just type in quick statements and get stuff running. Good way to test things, although my experience is for most practical applications, you still actually need to pull in all the classes, get the libraries set up, all that stuff. So you probably will never actually use it. But we will try it today on the Raspberry Pi and see if we can't get it working and run some simple stuff on it. And it's really good for just running quick commands, showing people things, testing stuff on the command line. So it's nice that we finally have a REPL in Java that actually works and is well supported. This is tangentially related, but Java 9 also adds HTTP2 support. So a lot of people use Raspberry Pis as web servers to serve up web applications to clients connecting remotely, because it's actually a fairly powerful processor inside of it. The latest Raspberry Pis have ARM version 9s, I believe. They have quad-core processors, and I think a gig or two of memory. I can't remember offhand. But basically, compared to the computers I started on when I was a kid, this Raspberry Pi is a beast. And it comes in a very small package, and it can run a web server serving up a handful of clients quite easily. So as an example, on the aquatic robots that James Gosling, the father of Java, creates as a part of Liquid Robotics, he runs a simple web server to serve up information about the robots that you can log into remotely over very slow connections. Sometimes they use those funky satellite communication links, and then you can get in there and make small changes to navigation or see video on the robots and do other stuff. Okay, actually it's ARM version 8, not 9. So this is the quick list of where Java 9 is supported and where it isn't. So the good news is Raspberry Pi 2s and 3s both work with Java 9, as well as x86, all the Intel Edison, Galileo, et cetera boards. The not so good news is that we've dropped support for ARM version 5 and 6. So if you have an older Raspberry Pi, if you have a Raspberry Pi A or B or B+, or if you have one of the new zeros, you're kind of out of luck. Stick with Java 8. This is less of a technical issue and more of a resource testing issue. So from a maintainability standpoint, there's different libraries for ARM version 7 and version 8. So backporting it and maintaining a version for the older libraries is extra effort in testing. So as a result, we've dropped that support so we can actually take advantage of some of the newer compiler features and not maintain duplicate versions of the code base. But if you have the older boards, you can still run Java 8 on it. So run the latest version with all the patches, and you should be fine. You just can't take advantage of Java 9 features. OK, and then some of the stuff which also doesn't work, or works but is not supported. So the G1 garbage collector actually works on Raspberry Pi, but it's not officially supported. So if you want to take advantage of the new garbage collector, you should wait until it's officially supported. It probably doesn't make sense to run G1 on the Raspberry Pi anyway, because the way G1 works is it actually takes one of your cores and uses that as a garbage collection thread. So it actually does a lot of the garbage collection in parallel. So it'll slow down your application. And on a small resource-constrained device like this, you'd actually, in general, prefer slight pauses, but higher performance, rather than pauseless garbage collection, but it's consuming additional resources on your device. The other thing which doesn't work is JavaFX. So we're no longer supporting JavaFX on embedded platforms, again, for resource issues. But you can use Swing and AWT. Those both work. There is a good option for doing JavaFX on the Raspberry Pi, though. The folks at Gluon And they're actually doing a presentation this afternoon as well. So Johan Voss, who runs the company, is out here. But basically, they support JavaFX on mobile and embedded devices. So they have JavaFX running on Android and iOS, and they also have it running on embedded devices like the Raspberry Pi. And I introduced them to Eben Upton, the guy who is the founder of the Raspberry Pi. And so they're working closely with Eben to put out a new version of JavaFX, which will work in X11. The current version of JavaFX, which is, was released by us and now Gluon is releasing, it only works on, it takes over the whole frame buffer. So you can't run it inside of an X11 application. It has to take over the full screen. So you get good performance, but it's not possible to run it inside of a windowing system. They have new graphics drivers for the new version of Raspbian, which they're working on, which is not yet released. And that's going to allow proper 3D performance inside of a X11 windowing system for applications running on the Raspberry Pi, kind of like a normal desktop operating system. So this will allow you to get direct access to like OpenGL low-level video hardware from inside of X11. And Johan's working with the Raspberry Pi Foundation to upgrade the JavaFX support to work inside the new environment. So you can download it today and you can use it, and it takes over the full screen. In the future, you'll actually be able to run it inside of a windowing environment as well. Gluon took over Scene Builder, which is a GUI builder for JavaFX. So this is a nice way to build JavaFX applications. And actually, I use this for the coffee demo, which is one of the demos we're gonna show in a sec. Yeah, there it is, the coffee demo. So this application for the coffee demo is actually written in JavaFX and deployed to the phone. You can actually scan that QR code or go to that URL and get the app on your device if you want to give it a try. But basically, the way this app works is we used it at Java 1, and we're using it at the Oracle Code events and some third-party conferences. Actually, we had this working for the CNC cutter here yesterday and the day before in the exhibition hall. But you get the app. Inside the app, there's a couple different options. One's for the coffee demo, one's for the CNC cutter demo. You can customize for the coffee demo the type of coffee, the strength of the coffee. And what it does is it has a Raspberry Pi program running connected to a coffee setup with a scale and a temperature sensor and a bunch of relays to control the grinders and the water kettle. And then it does a automated pour-over setup. So it gives the person, the barista, instructions on how to actually go through and pour the perfect cup of coffee. So this is one example of an application. The second one, which is the one we had running here, is a CNC cutter. So I'm using the Carbide 3D routers. If you guys want one of these. Oh, you did the experience, nice. And you got it printed for you too. Yeah. So there's 6 of these traveling around the world, and when they come back, I don't want them all sitting in my garage. So we use these Carbide 3D routers. They're really cool, fun toys. They use brushless DC motors. They have little Arduinos inside of them for the motor controller, but otherwise they're pretty dumb. And the way they get their instructions is serial over USB, connected to a computer or other embedded device. So I hooked up a Raspberry Pi to these. The Raspberry Pi sends G-code commands, which is the instructions for the motors, over GRBL, which is a serial protocol for sending G-code. There's the Raspberry Pi screen, like an early prototype. And it's hooked up to the CNC cutter, and it sends the instructions and then cuts out beautiful things like that guy. And what we used these for at Java 1 is we had an artist, Miria Wellman, who built a huge sculpture out of all the things which were cut from the attendees. So they cut out all these cool little shapes. And then we composited this big sculpture, and we unveiled it at the closing community keynote. Here's some of the code to connect to the CNC cutter. So, it opens up a serial port on the Raspberry Pi. It does some setup for English locale. I learned this we had a problem with this in Europe, because some of the guys I was working with this on had machines configured for weird European locales with where they swapped the comma and the period in numbers. And so when you send commands with commas and periods swapped, the Gerbil controller just goes crazy because it doesn't actually see those as numbers. But anyway, you set it up, open the COM port, and then you can actually start sending commands to the printer like all these nice G-code commands. This is the initialization procedure for the CNC cutter. It moves the head over. Like some of these are move commands. I can't remember offhand what all these are. This looks like a move command. Move to 0. Yeah, this is a relative offset. Some of these are speeds too. Like you can set the speed it travels at along with the commands. And then that's how it actually moves and then figures out the length of the tool. The other thing you have to do is you have to calculate the work plane offset, because once you know the length of the tool, you have to figure out the distance from the tool to the surface you're cutting on. And this is the coordinate system for the CNC cutter. So it has a X, Y, and Z. And you have a piece of material you're trying to cut. And then you need to figure out what the proper offsets are to get it in the right location to actually start cutting. And then you issue G-code commands to do the cutting. So this is G-code on the left, and then pseudocode on the right for what the commands actually do. So like G21 sets it to millimeters, then it sets it to absolute positioning mode, sets the speed to 9,000 RPMs, and then starts destroying the material. For this, we were using acrylic plastic, like that sheet he has over there. And the reason for that, you can also cut wood and you can cut aluminum, soft aluminums. But the problem with cutting wood at a conference like this is you get fine sawdust particles. And for people with like asthma or allergies or problems, that can irritate them. And technically, cutting certain types of wood, I think most types of wood are mildly toxic. So you don't really want to be breathing the dust. OK, and this is the command for the universal G-code sender, which is the library we're using to send the code from Java code. This is an open source project of varying levels of software quality. We had to fix some bugs in it. But it's not released yet, so it'll get better. OK, and then similar experience, right? You download the app. You can actually draw this on your phone. Did you draw on the touch screen or your phone? Touch screen. OK. So you should give the app a try, too, just for kicks. Yeah. You can draw it on your phone, and then on the device, you press the scan button, and you scan the QR code you get back, and then it will actually show the same drawing on the screen that you can cut out. So fun stuff. OK, so we're going to play with the line. It looks like you guys are done.
Yeah.
Are we timed perfectly here?
Yeah, that was great. We even added a hill obstacle.
Hill. Oh, nice. Nice. Yeah, you guys did a good job. OK. So we're going to play around with the line follower, which is this guy. And so this is a little robot which is constructed using Big Kid Legos. So this is made using the MakeBlock set from, there's a company in Hong Kong called MakeBlock. And they have this cool stuff which they build. They're kind of a maker company. And they use extruded aluminum, which is really strong. And they have this special design where all along the channels you have this little slit with ridges in it. And you can screw at any point along the line. So it allows you to do fairly flexible design of different structures using simple extruded aluminum and some screws and some rivets, plastic rivets and screws. So it's a really cool idea. They've actually built full 3D printers and all sorts of complex stuff using their using their construction technology. And this was one of their first designs, was just building, basic robots. So this guy's a tank robot that I kind of freeform designed using their stuff. It has the line follower on the bottom. It has a distance sensor on the front. So this is, the safety sensor. We'll test it and see if it works. But the idea is if you get too close to it, it's supposed to not run you over. And it has, a couple motor controllers for controlling the left and the right motor. So hopefully he'll actually go around and do the right thing. Let me get the Wi-Fi network he's expecting set up as well, so he can talk to us. If you notice, the design of this is it has a board on top with a bunch of telephone jacks, so it makes wiring a little bit easier than if you had to wire up all the sensors by soldering. But their basic design is for Arduino boards, and I wanted to do a pure Raspberry Pi design. So I'm using this board in the middle. I think I have a picture of it. Yeah, this guy here, the RP600. So it's a dumb adapter from Raspberry Pi to Arduino pins. A lot of these adapter boards, which you find for using Arduino shields, they actually have Arduino chips on them, and then you talk to the Arduino chip over serial, which I think that's silly. Just get an Arduino at that point. And part of the point was I wanted to actually do direct control of motors using pulse width modulation. So you can do PWM or pulse width modulation from the Raspberry Pi directly. You can do like simple control of sensors and different things from the Raspberry Pi. And I wanted to directly do that using a Java library rather than going to Arduino and offloading the work. But this is the full kit of everything you need. It's basically, the make block starter robot kit, plus a Raspberry Pi, their Uno shield, and the RP600. I think these come with the starter kit as well, the line follower and the motor driver. Okay, and then this is the code for getting the GPIO pins with the Pi4J library. So I'm using the Pi4J library for this. And then the next slide is the line follower algorithm. But let's see if we can actually get in this guy and do something. We actually have access to the guy. Okay, so we're gonna SSH into him. Okay, so now we're logged into the robot. Can you guys see the terminal? Is it big enough? Okay, I know you said it's big enough. Let's make it even bigger. So you see I have a version of Java 9 installed on here. And let's just prove that we're actually doing, yeah, so it's an early access Java 9 release. And we can run JShell as well. So I promised we'd do some JShelling. So, doing JShell from the command line on something without any interesting libraries is not all that great, but we can do basic stuff. Like we could do hello Devoxians. And normally if you did this from like a Java program, you'd have to write the whole public static void main class, and you'd have to have imports, and you'd have to do the whole jiggermal. But JShell kind of lets you just randomly type things, and you can even do simple control loops and stuff. Raspberry Pis can count to I. So we should get a bunch of, yeah. Okay. So Raspberry Pis can count to 99 apparently. So, you can do simple stuff on it, but yeah, that's about all we're going to do with that. That wasn't the right command. I think it's a /exit. Yeah, okay, there we go. And there's also help commands in there to do basic stuff. So you can import classes and you can, have variables and do all the usual stuff you're used to doing. Okay, but when you get tired of playing around with that, just open a real IDE and then get your job done. So NetBeans has a really convenient integration with the Raspberry Pi where you can actually set it up as a remote debugger. And that way you can do like debugging, performance profiling, and remote execution on the Raspberry Pi. I think IntelliJ added this support as well, or there's a plugin for IntelliJ which does exactly the same thing. I have not played with the Eclipse support. Now that the Eclipse guys run this conference, I guess I should have technically brought a great Eclipse demo, but maybe they'll forgive me. Apologize if this is slightly small because I don't have a lot of control on fonts. When we get to code, I'll adjust the fonts, but the general editor fonts are a little bit tiny. But you can add a new platform, and if you choose Remote Edition, then you can actually say, devox Java 9, linepy.local, put in your username and your password, and then you have to specify the remote JRE path, which is something. HomePy JDK9. Maybe that'll work. I don't know. But once you get it set up properly, then you can actually set it up as a remote debugging thing and use that from inside of all your applications. So let's give that a try. So I have this line runner code. Okay, so we can definitely make that bigger. So this code it's pretty straightforward. So it's like the same code I had on the board for getting the pins. Where are the pins? Yeah, so this provisions a few pins using the Py4j library. And then it creates pulse width modulation for the two motors. The way pulse width modulation works is like if you turn on a motor, it goes at full speed. And so the standard way to control motor speed is you give it pulses of electricity, so which will slow it down. And the nice thing about pulse width modulation is it lowers the speed, but it also lowers the power requirements. So you're actually using less power to control the. Did you guys have any tape left over at all? How about the black one? Any black left? No, I just need a little, actually I can use the white. I was thinking that last time I ran this demo, my battery fell off. And this would prevent the battery from falling off, which I think would be nice if the battery didn't come off in the middle of our trial run.
What are you using as the battery?
So this is a random USB battery. So originally the design was that it was back-powered off of the, I have a bunch of AA batteries which are driving the motors. And that works great for a while. And then if the motors get stuck, the draw of the motors increases, and then the voltage to the Raspberry Pi drops, and you reboot. So you could probably design a protection circuit or a capacitor or something which would allow it to live through the voltage surges and actually keep going. But I added a USB battery to work, so that was my hack. I'm really more of a software guy who dabbles in hardware rather than the opposite, a hardware guy who is pretending they can write software. I assume you guys are mostly in the same category as well if you're here at a software conference. Okay, so anyway, the pulse width modulation is fun. You can set the speed. The other funky thing, actually the line follower part's super easy because the line follower has two light sensors. It uses an ultraviolet light or something. It bounces that off the ground, and then it has a sensor which picks up the reflection and tells you whether it's black or white. But it has 2 of these, and it's just a simple on-off. So you get a pin back for like high is black and low is white, or vice versa. And then the algorithm's really simple. If they're both white, then you're lost because we're in the floor somewhere. We don't have a line to follow. So the default is just keep going with the last direction you had. If the left is black and the right is black, then you're on the line. You want to go straight. If the left is black and the right is white, then you're slipping off to the right, and you want to make a left turn and vice versa. So that's how it follows. And you'll see this when it's running. Sometimes it gets a little jerky because he's straddling the line and like going left, right, and constantly going off both edges. The other interesting thing to point out in the code while we have it open is the front sensor, the distance sensor, was the trickiest one to get working. And the reason for that is it's an ultrasonic sensor, but it's really designed to be an analog sensor. And so the way it sends back the distance is in microseconds. So it has a multiple number of microseconds for how far away the object is, with a higher number for greater distances and a lower number for shorter distances. And so like small dedicated devices like Arduino, which are single-threaded and they just go and constantly check state, this is great. They listen to the sensor, they check how many microseconds it is, and then you get extremely accurate, reliable, repeatable results. When you're running this on a Raspberry Pi with a preemptive multitasking operating system like Linux, unhappy because it has random pauses. And then you stack Java on top of it, which has a garbage collector and all its extra levels of abstraction, and it's even less happy. So what I did for this is I switched over. The regular Pi4J library is too slow for this. So what I had to do is I had to go down to their low-level protocol, which is basically a thin veneer. It's a thin JNI wrapper on top of the wiring Pi library, which is a C library. And so just using those direct calls via JNI, it's actually fast enough to do microsecond timings to a point. The sensor works to about a foot. And if it gets shorter than that, the timings are too short, and then it misses. But it mostly works for the purpose because, once you're a foot away from somebody, it's time to stop. Okay, so let's give this a try. So I'm gonna randomly run this and hope it just starts working. And then we'll test the track. Okay, well that's half working. Okay, there we go. Loose cable. Okay, so where should I start them? Anywhere? All right, let's just go this way. Oh, and feel free to stand up and walk around. Okay, so once he's started, it doesn't actually matter if he stays connected to Wi-Fi because he's autonomous now. And hopefully he's gonna make it around. Okay, so it's pretty good. You see he kind of like jerks around a little bit, but he eventually makes it. So what are the special features of this track from our designers?
Well, it has extra corner protection with extra weight.
See, that's actually really important. So it's a minor point, but on the corners, it's hard to get the black perfectly lined up. And if there's not enough white, then he just goes off because he'll probably see the round as black, is my guess.
And so our big special feature is we have a hill obstacle because why the hell not?
Okay, so that's the big challenge. See if you can make it over the hill. Well, yeah, there's enough clearance. He might just blast his way through it.
That'd be great.
We'll see. Oh, and actually, we need somebody to be the obstacle to see if he'll stop as well at some point. Oh!
Oh no! Poor little tank.
It was a good try.
Wide enough.
Yep.
Yeah.
There we
All right, there we go. All right, so somebody has to stand in the track and see if it'll stop for you.
Go ahead. Oh, there we go.
Well, I wouldn't leave something that small. He might not. Oh, all right, it stopped. All right, so big round of applause for our track designers.
Could you have programmed it to stop at specific points on the route? Like, let's say you were actually doing this to deliver stuff, and on the route, you needed to stop at specific points.
Yeah, okay, so that's
Those points.
Color sensor would probably be what we need then. Yeah.
that's a good question. Actually, I was thinking about doing this to have it like shuttle. So I have another version of this robot which has a grabber, and so he can grab a ball, and then he can run with the ball, and he can deposit it somewhere. So actually, I was thinking about doing patterns with the black and white lines. So if you saw a certain pattern, it would open or close the gripper.
But if you saw that pattern, it could just stop too.
Yeah. So you could have like different, because I mean, with if it doesn't see a turn, if it just sees like on off, you could use that as kind of like a code to send it, to give it instructions. It would keep going straight while it's reading the code. And then when it gets the code, you could have it stop, or you could have it do different instructions. So I think you could actually design little codes into the track at different points to have cool behavior.
So, like, how many milliseconds is between when it can read? Because essentially, since it has a constant speed, you just have to remake stickers with white and black stripes in it.
Yeah. But I mean, I think it's, I'm not actually sure how often it's sampling, but I think it's pretty often. Like it shakes around a lot. So you could probably, within like 2 centimeters, give it a code with at least 16 bits or something.
Yeah, that'd be cool.
How did you get the code onto the Pi? So you built this in you wrote the code in NetBeans,
Yeah.
but it's executing on the Pi, right?
Yeah, so I'm actually remotely hooked up to the Raspberry Pi in this case. So the Raspberry Pi has a Wi-Fi dongle on it. And while I was talking, I hooked up a small Wi-Fi router to my computer. And the Raspberry Pi knows to hook up to that Wi-Fi network. You could also hook up an Ethernet cable. The Raspberry Pis have Ethernet on them. Or you could just copy the software to the SD card and then run it autonomously on the SD card.
Could you have like deployed a jar to it? And
Yeah.
started the jar up on the
Yeah, actually, that's all NetBeans is doing. Is it copies the jar over, and then it runs the Java command to execute the jar file. But it uses SCP to copy, and it uses there's an SSH execute a command thing, but it uses that to run the command remotely. Yeah, so the standard way, if you didn't want to use a specific IDE feature, would just be to copy the jar file over using your favorite SFTP client. And then you could log in with terminal and run it. And actually, assuming we're still connected to it, you can actually see the commands here. So you see here it actually is the command that's running. So it changes directly, does a sudo, runs Java. And then here is the, well, that's where it's making the directory. But if we look at the Pi itself, there's a NetBeans folder it creates here. And this is the line runner folder. And here's the jar file which it's running, the linerunner.jar.
So it would be logging while it's doing stuff, and you could be reading the logs in real time, and see what's going on with it?
Yeah, absolutely. What did I what? The only thing installed on the Pi in this case is I wanted to run Java 9. So here's the Java 9, the JDK 9 folder, which it's using. By default, the Raspberry Pi has Java 8 installed on it. So if you just want to run Java 8, you can take a plain Raspberry Pi with nothing special, just the standard Raspbian installation. And you can remotely execute using Java 8. So you don't need anything special installed. All right, cool. Well, thank you guys for coming to the presentation. You can find more information about using Raspberry Pi and Java in the book which I wrote for McGraw-Hill together with Jim Weaver called Programming Raspberry Pi with Java, Programming the Internet of Things. That has, I think, this exact project. It has a 3D printed gaming console, which also runs the Raspberry Pi and runs half NES, which is a Java-based NES emulator. A Magic Hat, which uses an RFID card reader. So that's another fun project. And you can make your own RFID cards, or you can actually buy them. There's a bunch of companies which do poker tables, automated poker tables, and they sell RFID chipped cards with almost invisible RFID tags. And it also has a couple versions of the coffee demo, which I showed you guys. And if you have any other questions or you want to just chat, feel free to hang out. We have a few minutes before the next session, I think about 5 minutes or so. So thank you guys very much.